All right, let's jump right in. Today, we're doing more than just learning about Python. We are actually going to build your very first programming toolkit right from scratch. We'll assemble the fundamental pieces, the core syntax you'll absolutely need to start automating your world. Okay, let's get into it.
And listen, we're going to approach this in a really practical way. This isn't some dusty old textbook theory. Nope. This is all about understanding these tools exactly how the pros do. The folks in IT, engineering, and automation who use this stuff every single day to solve real problems.
So before we can build anything, we need to understand the blueprint, right? We have to get inside Python's head just for a minute and see the simple foundational rule that governs how every single script runs. And here it is. It sounds almost too simple, but trust me, this is the most important mental model you can have. Just imagine Python as this really patient, really methodical worker. It starts at the very top of your file, reads one line, does what it says, and only then does it move on to the next one. It never jumps ahead. Getting this down is the absolute key to debugging and writing code that actually does what you expect it to do. Now that we have the blueprint for how Python thinks, we need some raw materials to work with. This is all about how we store and categorize the information our programs are going to use. The most basic piece of raw material we've got is something called a variable. The easiest way to think about it, it's just a labeled box, a container where you can stick a piece of information. Now, what's really cool about Python is this thing called dynamic typing. It basically means you don't have to tell the box what kind of stuff you're going to put in it. You just put something in it, like, say, the number 10, and Python just figures it out on its own. It says, aha, this is a number box now. Of course, these boxes need names, and there are a few rules. As you can see on the good side, names like username work perfectly. But over on the bad side, you can see you can't start a name with a number, like in toName, or use special characters like a hyphen. Getting this right from the start will save you from a ton of simple, frustrating errors. So what kind of stuff can we actually put in our variable boxes? Let's look at the 4 fundamental types. First, we have integers. These are just whole numbers, for counting things. Then you've got floats, which are numbers with a decimal point, perfect for something like a price. Strings are simply text, like a name or a message, and they're always wrapped in quotes. And finally, booleans, which are the simplest of all. They're basically the on-off switches for our code, representing just true or false. Okay, get ready for a little bit of a brain teaser here. What do you think you get when you add 0.1 and 0.2? I mean, your brain immediately says 0.3, right? And you'd be totally logical, but computationally, you'd be wrong. This number right here is what Python will often give you back. It's this weird little quirk called a floating point precision issue. It's a classic gotcha that, believe me, every single professional programmer stumbles upon sooner or later. So we have our materials. Great. Now we need the engine, the part of our toolkit that can actually make decisions and perform actions. This is where our scripts stop being just a simple list of instructions and, they start getting smart. But wait, before we even think about building that engine, we have to talk about Python's number 1, most important, absolutely non-negotiable rule, and that is indentation. Just look at the screen. On the wrong side, see how that print statement is flush with the left? Python has no idea what to do with that. But on the correct side, that little bit of space at the beginning of the second line, that's not optional. That is how you tell Python, hey, this print hello line, it belongs to the if true line right above it. It's what creates a block of code. And this quote just brilliantly nails the point. In a lot of other languages, how you indent your code is just for looks. It's a matter of style. In Python, it is the syntax. The language literally requires it to understand the structure of your program. Get the indentation wrong, and your code simply will not run, period. With that rule locked in, let's see how Python makes a decision. It's a really simple top-down flow. First, it checks the if condition. Is the score 90 or above? If it is, it runs that code and it's done. But if it's not, it moves on to the elif, which is just short for else if, and it checks the next condition. And if all of those fail, it just falls back to the final else block. The other half of our logic engine is all about repetition, and for that, we have loops. A for loop is an incredibly powerful tool for doing something to every single item in a sequence. This one line of code here is basically telling Python, hey, I want you to walk through the word Python, and for every single character you find, I want you to do something with it. And here's what you get. The loop grabs the P, prints it, then it moves to the Y, prints it, and so on, all the way through the word. This is the real magic of iteration, taking a repetitive, boring, manual task and automating it with just 1 or 2 lines of code. It's awesome. Okay, so we have all these individual tools, but as our scripts get bigger, we can't just have loose variables and loops floating around everywhere. We need a way to organize our tools into reusable components and to put our data into structured containers. Functions are our reusable components, and one thing that often trips people up is the difference between parameters and arguments. So think of it this way. When you define a function, the parameters, like a and b on the left, they're just placeholders in the blueprint. But when you actually use the function, the arguments, like the 5 and 3 on the right, those are the real materials you're passing in to get the job done. And for organizing our data, we've got 3 main containers. First, you have a list. Think of it like a shopping list. It's an ordered collection that you can add to or change anytime you want. A tuple is similar, but it's like a list written in permanent ink. It's immutable, which just means you can't change it once it's created. Finally, we have dictionaries, which are like a digital filing cabinet for storing data using key and value pairs. And we'll see in a second why these are so incredibly important. So you might be asking, why are we geeking out about dictionaries so much? Well, in the world of IT and automation, they are everything. Why? Because they perfectly match the way data is structured pretty much everywhere else. When your script talks to a web service using an API, the data you get back is almost always in something called JSON format. And guess what? JSON is basically a dictionary. Configuration files, system states, it's all key value data. Dictionaries are quite literally the native language for modern IT. And just like that, you've assembled a complete foundational toolkit. You've got the blueprint, you've got the raw materials, the logic engine, and the organizational components. Now let's just do a quick review of what's inside. So here it is, your mastery checklist. If you followed along, you now get how to make decisions with if-else logic. You can automate repetition with loops. You can package up your code into functions and organize your data with lists and dictionaries. And most importantly, you understand that non-negotiable rule of indentation. You have the core skills. You are ready. So that brings us to the end, with just one final question. We've just spent this time carefully putting together your starter toolkit. All the pieces are there. They're sitting on your digital workbench, shiny and ready to go. So the only real question left is, what are you going to build first?